Hello, guys and gals. We're going to talk about water and its properties. We left off yesterday talking about adhesion, which is water's attraction to other surfaces like glass or the cellulose of paper towels or this leaf here or the spider web. So the polarity of water also affects the boiling and freezing point of water. We can see the water melts and freezes at 0 degrees. When compared to other small molecules, it has a relatively high, because these are very negative numbers, has a relatively high melting and freezing point, which makes it a liquid at room temperature. And it also takes a lot more energy to boil water. So ammonia is probably the closest in properties to water because it's a very similar mass, and ammonia also has hydrogen bonding, but notice that its boiling point is a lot lower than that of water. So water has a really high boiling point because in order to get it from a liquid to a gas, you have to completely separate the little molecules, which means you have to break all of the 4 hydrogen bonds that hold it into that liquid phase. So water has a high melting and a high boiling point. We talked a little bit about boiling points at various altitudes. Oops, sorry about that. So at higher altitudes, like Idlewild would be somewhere in this range, it might boil at only 94 degrees. And you guys said that was because it's easier for the liquid molecules to escape and turn into a gas because of the lower air pressure. And that is correct. So it's easier to break them apart with less pressure pushing down on the surface of the water. Water stabilizes air temperature by absorbing heat from warmer air and releasing heat into cooler air. So it keeps the temperature more stable, and it can absorb or release relatively large amounts of heat with only a slight change in its own temperature. So for reference, water boils at 100. Our body temperature in Celsius is 37. Room temperature is about 23 degrees, and water freezes at 0 degrees. Now, these are all Celsius, which we use in science. We don't use Fahrenheit. We use Celsius or Kelvin. What is kinetic energy? Kinetic energy is defined as 1/2 mv squared. But I want you guys to equate kinetic energy with the motion of the molecules. Okay, so kinetic energy is how fast they are moving. Heat is a transfer of energy. So if you have a hot cup of coffee on a cold day, the little water molecules in your coffee are going to be moving around really fast, and they're going to be transferring some of that energy to the air above. Okay, and that's why you see the steam above the coffee, because some of that energy, some of the water is escaping, but it's also transferring its energy into the nitrogen and oxygen molecules that are above it. So heat is the transfer of energy. Temperature is the average kinetic energy. So the average of how fast they're moving, because sometimes they move, you'll have one sample and one molecule will be moving faster and another will be moving slower. But the average of the kinetic energy, that is temperature. So we use a thermometer to measure temperature. When you put a thermometer in your hot water, the little water molecules are going to bump into that bottom red part of the thermometer, and heat is going to transfer from the water to the red liquid inside, and it's going to cause the red liquid to move faster and have a higher kinetic energy, and that's going to push the red liquid up the thermometer. Okay, so temperature is a measure of average kinetic energy. Heat is the transfer of energy, and kinetic energy is how fast they are moving. Specific heat is how much energy is required to raise the temperature of something. So we're going to look at specific heat next. The units for measuring heat, we use a joule sometimes, which is the SI or International System Unit for measuring heat. In food chemistry, you're going to see we talk a lot about calories, and we're going to come back to calories as well. A calorie is the amount of heat required to raise the temperature of 1 gram of water by 1 degree Celsius. And it just so happens that it takes 4.18 joules of energy, that's the SI unit, to raise the temperature of 1 gram, which is less than a teaspoon, it's a tiny bit of water, by 1 degree. So 1 calorie is defined as 4.18 joules. Specific heat, we just said this, it's the amount of heat required to raise the temperature of 1 gram of a substance. So we can compare that 1 calorie of the water to other substances and see how much heat is required to raise their temperature by 1 degree Celsius. So water is 4.18. That's how many joules per 1 gram. And notice this is a capital K for Kelvin, but you can use Celsius or Kelvin interchangeably here. So we can put a C or a K, doesn't matter, it's temperature. So joules per gram Kelvin, water takes 4.18 joules to raise the temperature by 1 degree. All these other ones down below, ice, aluminum, copper, lead, they're all much, much less than water. So I want you guys to remember that water has a relatively high specific heat. If you had 2 samples on the stove, if you have a container with water, and then you had a block of aluminum, the aluminum only requires, it's less than 1 joule for the temperature to go up. The water requires 4 times, more than 4 times that amount. So if you had aluminum on the stove and the same amount of water on the stove, and you wait 5 minutes, you definitely don't want to touch the aluminum. It's going to be really hot. The temperature will have gone up a lot. And the water after 5 minutes might not be that warm. Okay, so you have to add less energy to raise the temperature of these metals down here. And you have to add more energy to raise the temperature of water. Water has a high specific heat. Okay, here's a summary of that. So because water resists temperature change for both heating and cooling, it can absorb and release large amounts of heat energy with only a little change in its actual temperature. Specific heat prevents temperature fluctuations that are outside the range suitable for life. They cause coastal areas to have a mild climate, and they stabilize marine environments, like over here. Specific heat and climate. So how does water contribute to the moderate climate in coastal communities? We're comparing Santa Barbara to an inland community, kind of like Hemet versus Oceanside. So you'll see that the temperature range tends to be a lot bigger inland. It gets hotter and then colder because we're surrounded by rocks. And in the coast, like Oceanside or Santa Barbara, it doesn't get as hot and it doesn't get as cold either, because that water is going to stabilize the temperature. So in July versus December, you guys can look at the range in their temperatures. That's the difference between the high and the low, and see that there's a bigger range when you're inland versus when you're on the coast. It doesn't get as hot. Look at all these nice temperatures, and it doesn't get as cold. All right, that's it for today.